Alright, let me try and use this to quickly explain why the temperature during phase change remains constant. Now, this is a phase change diagram of water. So an example is water. And now if you look here, water, when it's below 0 degrees Celsius and 0 degrees Celsius, water is completely solid. Now, when you're adding heat to it, as the heat is increasing, you can see that the heat is increasing from left to right. The temperature, though the temperature starts increasing, but the substance is still solid because not enough heat or energy has been absorbed to break apart or to separate the particles. Now, once it gets to 0 degrees Celsius, at this point, enough energy has been added to begin to separate the particles of the solid into the liquid. So that is what is happening here. You can see during the melting, freezing is also taking place. So this is where a phase change is happening, when the solid is changing to liquid and then the liquid is changing back to solid, which occurs at 0 degrees Celsius. Now here, during this phase change of melting and freezing, the temperature is not increasing, as you will see, because it remains uniform, because not enough energy has been added to separate all the particles that were combined in the solid form. Now, at this point, at this particular point here, when the temperature begins to rise, it shows that means that all the particles in the solid have completely separated. That means enough energy has been added to completely separate these solid particles into the liquid particles before the temperature begins to rise again. So you can see when the temperature begins to rise, it's completely one state of matter. Here, when the temperature is rising, it's liquid. Here, when the temperature is rising, it's solid. So at this point, more heat is being added to the liquid phase. Now, when enough heat energy has been added to begin to separate these liquid particles into gaseous form, the temperature will remain constant until all the liquid particles have been separated into the gaseous phase before the temperature begins to rise again. So at this point also is where a phase change is happening, when the liquid is changing to vapor, which is vaporization. At the same time, the vapor, our gaseous form, is condensing back to liquid. So here, during phase change, the temperature remains constant. It doesn't change. The same thing happens here. During phase change of melting and freezing, the temperature remains constant. I hope this helped, and let me know if it doesn't. I will try and explain it in another way. All right, thanks. Good question.